we will discuss the static 1 hazard and static 1 hazard cover. To understand the static 1 hazard, let us take an example of an OR gate where one of the input is A, another input is the complement of A. In this particular scenario, the output will be always equal to 1 because one of the input is A, another input is a complement of A. Now let us take a scenario here that when the input A, there is a transition from 1 to 0. That means when it was 1, output 1 and complement of A was 0. Now when it is changes from changes from 1 to 0, the input A immediately become 0 here, but due to the delay in the NOT gate, the complement of A remain to be 0 for a period of time. As a result, during this period, both the input to the OR gate becomes 0 and the output is become 0. After that durations, the complement of A will become 1, again the output will become 1. That is shown in the graph also. You can see here this is the A, signal A, and it from 1 to 0 transition takes place, but the complement of A do not takes place, transition do not takes place immediately. It takes some time, period of time T1 it takes, and then it changes to 1. During this period of T1 time, both the A and the complement of A remains to be 0, and as a result the output Y will become 0 during this period of time T1, and that is not desirable in some circuit, as example sequential, mainly the asynchronous type of circuits. This type of things are undesirable. And you can see the Y, that means the output also. You can see due to that, both during this period of time, T1 period of time, both are 0, therefore output will be 0 for again T1 time, and that is shown here. But this output of the OR gate immediately do not become 0 when both of them was 0. That is also because there is a delay in the OR gate also. Therefore, after the period of T2, that is reflected in the output. That is shown here in the output of the OR gate. And T1 is the NOT gate delay and T2 is the OR gate delay. Now we'll discuss the static 1 hazard cover. How to make a circuit free from static 1 hazard. Now let us take an example of a Boolean functions which is shown here, and this is shown in the main term. That is the summation of the products, and that we simplified it with the K-map. After simplifying with the help of a K-map, we got the minimized expressions in the sum of products forms. And then this minimized circuit, minimized form of the Boolean expression is drawn here in the basic gates. And this will show that now this basic gates is not free from the static 1 hazard. To understand that how it is there is a static 1 hazard, let us take in one example when A equal to 1, B equal to 1 and C also equal to 1. Therefore, in that case you can see this is A equal to 1, C is also equal to 1. Therefore, output will be equal to 1. Therefore, the output is equal to 1. Now let us take a scenario when A do not change, that means A remains to be 1, B remains to be 1, but transition of C takes place from 1 to 0. In that case, A is 1, C is become 0. As a result, output of the, you can say this is a gate number 1, you can say, and output is become 0 immediately because C has become 0. Now, because of the delay in the NOT gate, which was 0, remains to be 0 for a while, because when C becomes 0, immediately the complement of C do not happens because of the delay in the NOT gate. Therefore, it would not become 1 immediately, it will remains to be 0 for a while. As a result, what is happening? B is equal to 1, one of the input to the AND gate, and another input remains to be 0 for a while. As a result, what we are getting here, also output is gate number 1 output is also 0, and the gate number 2 is also output is 0 for a duration, for a small duration of time because of the delay in the NOT gate, and as a result Y will become 0 for a small period of time, and that is the static 1 hazard which is present in that circuit. Now let us take a same Boolean expression what we made into the minimized form. In that Boolean expression, we are showing that another group is being added, which is the group, this is the group has been added. As a result, another terms has been added, which is AB. And due to that additions, that is AB, due to that addition, that modified circuit is free from static 1 hazard, because in the previous case, when C changes from 1 to 0, that not due to the NOT gate delay, it remained to be 0. But because of the addition of another gate here, because A and B remains to be 1, and therefore the effect of gate number, you can see if you number it 1, 2, 3, the effect of the gate number 2 is being neutralized by this addition of this gate. Therefore, if it changes, it will become 0 immediately, and due to the transition of time, it is also 0, and because of the delay in the NOT gate, but A and B do not change. Therefore, this is 1. Output is 1. Therefore, output will remain to be 1. Therefore, this has been neutralized, and that by the another addition of a gate, which is A into B, and that we can say that static 1 hazard, it is free from static 1 hazard, this circuit. Now, there is an important thing is that we minimize a Boolean expression, and then the minimized Boolean expressions, what the circuit we get, always it is not free from static 1 hazard. Therefore, sometimes additional circuits are required to make it free from static 1 hazard.